So we're reviewing for summative number 8 in fall of 2019 for PreCalc. We have worksheet 15, 17, our reference sheet, and our review worksheet out. So the first question, you guys are asked to list all of the possible rational roots. So your list should start off with a nice big plus and minus symbol, so you don't forget there's positive and negative of all these. And then you start by listing out all of the factors of your constant, which are 1, yes, 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 very good. And then you're going to divide all of those by all the possible factors of your lead coefficient, which are 1 and 2. Now, if this is where you stop, this would not be right. So you can do better than this pre-calc. Ready? We have positive and negative on all these. If I divide all these by 1, then it's just those green things again. So I'll just list them out. And then if I took all those green things and divided them by a 2, I would write down a 1/2, but I'm not going to bother writing down a 2 halves, a 4 halves, a 26 halves, or a 52 halves, because those are all things we already listed. But I would totally write down a 13 halves, because that is not listed yet. Okay, so I don't know if you can read that, guys, but it says positive and negative 1, 2, 4, 13, 26, 52, 1/2, and 13 halves. So now you are going to go to your calculator, and you're going to type in the original polynomial into your, should be a standard window. Look at the graph. And with this being a quartic, I need you to at least give me 2 places where you see it hitting the x-axis that are nice. And they have to be from this list. So if you think it hits at, negative 3.5, you're wrong, because that's not in your possible rational root list.
Then why is that there?
There's 2 ugly ones.
Yeah, but there's ugly ones here, too.
Mm-hmm. Because they're not rational. They're irrational. We'll see when we get to the end of the problem.
It says all 4, but there's...
Right. We'll get you. I got you. Once we get down to the quadratic, we'll be able to handle it. Okay? Are you guys... You're annoying. All right. Did you guys... Did you guys see 2 nice places where it crossed the x-axis?
Negative 2 and 1.
Okay. Negative 2 and 1 is what we should use. So we're going to successively divide them to whittle it down to a quadratic. Once it's a quadratic, we can handle this. Which one do you want to use first?
Negative 2.
Wow. Great. All right, so our coefficients are 2 and 2 and negative 30. Oh, it's a long one. Oh, boy. Negative 26 and 52. Now, unless you lied to me, what should my remainder be? Should be a 0. All right, let's see. That's a 4. Negative 26. That's a 52. So that's a 26, and that is a negative 52, which does indeed give me a 0 remainder. Nice job, guys. All right, use your smaller depressed polynomial coefficients and do it again. This time with the other 0 at 1.
And that is, so you actually plug in an actual 1, not a negative.
Right. If it's a factor, you change the sign around, but this is a 0. All right, so this is kind of weird. But it does give you a remainder of 0, so I know you didn't lie to me about that. That's good.
What would they possibly lie to you about?
I mean, I say lie. It's a strong word for, like, misinterpreted the graph.
Oh, okay.
You're very sensitive about that, I know. Okay.
So it doesn't matter if you did 1 first?
It doesn't. It doesn't. You'll still get the same final depressed polynomial. By the way, those are just coefficients. I need someone to translate that to me. What does that say?
2x squared.
Yeah.
Minus 26.
Right. Cool. Now, I'm a little sad about the order in which this problem asks you to answer it, because this is where I think a lot of kids get confused. I want you to list out all 4 of your zeros for me. So if I were to set this guy equal to 0, most people would add the 26 over and divide by 2. They'd eventually get x squared equals 13. And when they square root both sides, they get x equals positive square root of 13 and negative square root of 13. But all you listed out for me right now were 2 zeros. And notice, guys, these are not rational. They're funky, irrational numbers. That's why you were seeing weird little things on your graph that weren't from that nice list. It's like the naughty and nice list from Santa. With all the snow on the ground, this is a very appropriate metaphor. Okay, so that's not enough zeros because you started with a quartic. Where are they? Yes, the original ones you gave me from the calculator, these guys. So the other zeros are at negative 2 and at 1. So this is where kids start to get in trouble on this question because they're like, okay, well, I'm going to take all those zeros I just found and I'm just going to throw them into factors, because this question, it's not worded real specifically. All I want is factored form with irreducible linear factors, or possibly irreducible quadratic factors. So there's a little bit of interpretation that, like, I'll accept different answers here. So what most kids do when they get it wrong is they say, well, I've got x minus square root of 13 and x plus square root of 13. And then if they throw the minus 2 back into a factor, they have x plus 2, and they have x minus 1. And this is wrong.
Why?
I'm asking you that. Why? Tell me why it's wrong. Well, without doing too much math, I can tell that this does not match the original function based on its lead term. His lead term is 2x to the fourth, and this guy's lead term is 1x to the fourth. We've lost our lead coefficient in our math. Can anyone spot the moment that we lost the 2?
No, because he didn't show you.
Burn, man. All right, right here. What did we do in our math? We added the 26 over and we divided by 2. Boom, right there. You lost your 2. Okay, so when you solve an equation, you lose coefficients. It's not the end of the world. Like some of you yesterday, when we did a question like this, you're like, well, I don't care. I'll just put it back at the end of the problem. I'm with you. You got to remember to do that, though. Okay? So,
it seems like cheating.
It's just recognition that you lost your factor. Okay? Your lead coefficient, I should say.
So I won't get
It's,
because it doesn't follow my work.
no, because what I'm looking for is that you know the 2 is there. Now, here's what I would say. If you're worried about that, and you're like, I'm not going to remember that, then what I suggest you do is you go to the end of your synthetic division step and write him as one of your factors. And then continue on with the other factors that you had from the calculator. You don't.
No?
You don't. And this is where there's a little bit of interpretation. Some math teachers, me, would call this an irreducible quadratic. I mean, yeah, you could factor the 2 out of it and get x squared minus 13, but
then you still really have a square. Or
right. This is advanced factoring. Like, we don't, like, as a normal human doing math problems, if I saw x squared minus 13, I wouldn't be like, I should totally factor that. That's a weird factoring question, okay? So I actually like this question, this answer right here. I like it fine. So it depends on your technique, guys. If you take all of your 4 solutions, you plop them back into factors, just be aware that you probably lost a coefficient in your work. So watch out for that lead coefficient at the end. Okay, that's my only warning to you. Okay? Great, clear as mud. Let's move on. All right, so this is on worksheet 17. This is a question that looks a lot like what you're going to see on your test. And you're going to want to use your yellow card and follow those steps exactly. And then you'll be in good shape for... Remember, this test you get to use a graphing calculator for, which I know some of you are like, yay, I'm going to do this whole thing on the graphing calculator. And my answer to that is probably not. That's very slow, and you're going to run out of time. Well, it's not the typing that's the problem. It's the finding everything without knowing what you're doing thing. Really fast at making it up. Okay, so the first thing on my yellow card says you better factor everything. So let's factor everything. This becomes x minus 3 times x plus 1 in the numerator. And then my denominator, you can factor an x out. So x times x minus 3. Uh-oh. What do you notice?
It's a removable.
There's a removable discontinuity. We'll get to that in a minute. All right. Don't remove it yet, because he is part of the domain. The domain is a listing of all of the things that would give you a divide by 0. So any type of discontinuity. So x cannot be 0, and x cannot be 3. Yes?
So just curious, I'm sure by asking the question I'm breaking the major balance rule, but I'm going to ask it anyway.
Go ahead.
Why can't you just get rid of the x squared right away?
That is not an x squared.
Is it x squared minus 3? Oh, I didn't see the parentheses.
That's a good point, Daniel. They're called implied parentheses. Don't you like math? It's like they just make crap up. Like, well, when I write it like that, I meant to put parentheses.
So I'm going to tell you, like, I meant to make that a negative, but I figured you'd understand.
You don't. It was an implied
you
negative, Mrs. Abruzzo. I implied that answer was not that answer, and you can try. All right, so right away, Daniel pointed out there's a removable discontinuity. This factor is going to cancel, but talk to me about what is the x value for the location of the hole.
3.
It's positive 3, right? So the solution to that factor. Okay, from here forth, you no longer use the original problem. You're going to use the smaller version. This guy right here. This is the one you want to keep looking at from here on. So if x equals 3, I need you to throw a 3 into this new small guy. Don't go to the original. Yep, you got 4/3. So on my graph, because I actually am graphing this time, I'm going to draw a hole at 3, comma, and then 1.3 roughly. So like, yeah, sure, right there. Make sure I can see it. I got old lady eyes. All right, next, they want to talk to you about any vertical asymptotes. So again, you need to look at now this smaller version of the rational. There is a vertical asymptote. Where is it? At x equals 0. I need to see you writing this as a line. Okay, as a line. Grab your highlighter. Mark me a vertical asymptote at x equals 0. That will help me when I get to the graphing moment. All right, now they're going to ask you about x-intercepts and y-intercepts. So x-intercepts, you're supposed to take your numerator and set it equal to 0. So if you took x plus 1 and set it equal to 0, you'd be getting an x-intercept at -1, 0. Draw that on your graph. And then for y-intercept, you're supposed to plug in 0 for all of your x's. And again, we're going to this reduced version. So if you plugged in a 0, you'd get 1 divided by 0. What does that tell you? That you don't have 1. So that makes a lot of sense now that I go back and look at my highlighter line. Or how are you possibly going to be having a y-intercept when there's an asymptote at the y-axis? That doesn't make any sense. Okay, so there's none. Is this top heavy, bottom heavy, or equal weight? And again, you should be looking at the smaller one from here on. Equal weight, so you do have a horizontal asymptote. Located at y equals, the leading coefficients reduced to 1. You have a horizontal asymptote at y equals 1. Please use your highlighter and draw that for me. And I know I'm like the last person in the world who should be critical of your graphs, but I am pretty critical of these. So I want to see you guys kind of giving yourself visual boundaries for the asymptotes, so that way when you graph, if you're like super sloppy, I'm going to ding you a little bit, okay? Where are we at? Okay, so there's no oblique because it's not top heavy, so we're ready to grab our calculator, and I actually have a pretty good feel for what this looks like, mostly because I just did this question like an hour ago. So it looks like this. And if I can draw this on a tablet, you can make beautiful things on your paper, right? No. Yes?
Explain one more time what removable discontinuities actually are. Like, are they actually like a thing that's sometimes there, or like? Because the word removable, it seems like sometimes it's there and sometimes it's
removable is implying that algebraically you can remove them through factoring and canceling.
Okay.
So they are still a discontinuity, but they're not an infinite discontinuity like an asymptote.
Yeah.
They're removable in the sense where your factor would cancel each other out.
Okay.
But it doesn't like stop it from being a discontinuity. Like if you look at the original problem, if I wanted to say, oh, I can plug in x equals 3 whenever I want, the answer is no, you can't. Because if you plug it into the original problem, there's a discontinuity there. But the type of discontinuity is based on the algebra.
Okay, but so if you plugged it into the original, it wouldn't be there, but if you plugged it into
If you plug x equals 3 into the original function, you'd get like something divided by 0, which is undefined.
Right.
So at the value of x equals 3, your function is undefined because there's some type of discontinuity. So it's either a jump discontinuity, which this one isn't. It's either infinite discontinuity, which that one isn't. Or it's a removable discontinuity, which that's the kind it is. Okay, so it's based in how the algebra works out. If you can remove it through factoring and canceling, we refer to that as a removable discontinuity, and it looks like a hole. Okay. All right, this is on worksheet 15B. I can do these if you want, if you just want more practice finding all of the special little things, or not. All of them? Any of them? Some of them? None of them? What do you want? Domain? Okay. So got to factor everything, because anything that creates a divide by 0, whether it's a hole or a vertical asymptote, it's still a domain issue. So let's see here. That would factor into 4x plus 1 and x plus 1. So my domain issues would be x can't be negative 1/4 when I solve this one. And x can't be negative 1. Now, this numerator factors into 2 times x minus 3. So there's no canceling factors anymore. There's no removable discontinuity, so there's no holes, which means that both of these discontinuities are vertical asymptotes. So a lot of kids get confused because they think like whatever they write down in the domain is also their vertical asymptote. That is only true if there's no holes. The other thing I want to point out to you guys that I saw in the last test, I had a lot of kids not write down equations for their asymptotes. It has to be an equation because it's a line. So horizontal asymptote is it top heavy, bottom heavy, or equal weight thing. And it was bottom heavy. So according to my yellow card, bottom heavy has a horizontal asymptote at y equals 0. The zeros, that's another word for x-intercept. You're supposed to set your numerator equal to 0 and solve it. So in the factored form, guys, this tricks a lot of kids. They think the 2 can be 0. 2 does not equal 0, no matter what you do, okay? So the only 0 that you're going to get here is at x equals 3. I would like you guys to write that as an ordered pair, though, okay? I want to know that you understand x-intercepts are x comma 0. And then a y-intercept, you're going to plug in x equals 0. I would just go to the original one, which I can't see anymore. But I think if you plug in a 0 for all your x's, you got like 0 minus 6 over 0 plus 0 plus 1. So that simplifies down to a negative 6. So 0 for x and negative 6 for y. And remember, you got a graphing calculator, so if you're in a jam, you can kind of get yourself out of it, but that will slow you down significantly, and this is kind of a beast of a test, so you don't want to depend on it too much. Okay, wow, big miss on the last test, guys.
Okay.
Okay.
As x approaches.
No, that is not what I'm looking for. Okay, end behavior asymptotes on rational functions are either a horizontal asymptote or an oblique asymptote. That's what end behavior means on a rational function, okay? They're either going off to a horizontal asymptote or they're going off to some sort of slanty thing. Okay? I know you got that skeptical look. Well, I implied...
Sorry, no.
Now you know. So that example that's right above this question, do we have a horizontal asymptote or an oblique asymptote, and how do you know?
It's oblique? No, it's horizontal because they're equal weight.
Okay, that's an equal weight rational. So it has a horizontal asymptote.
Yay.
So this one has a horizontal asymptote at y equals 1.
How is it y equal 1?
Because when they're equal weight...
Quadratic over quadratic. You got 1 over 1.
Oh, yes.
Mm-hmm. So your question, Taylor, it's equal weight because it's a quadratic over a quadratic. It doesn't have to do with how many terms are in it. It's the highest degree, the highest exponent, the degree of the poly. All right, now this next question, when I ask you for the end behavior equation, notice the word equation being bolded. That's not an equation. Does this one have a horizontal asymptote or does it have an oblique asymptote? Okay, why is it oblique this time and not horizontal? This one is top heavy. See it?
Mm-hmm.
So when I have an oblique asymptote, I find that through the art of division. Your choice, synthetic or long?
Synthetic.
That was a quick synthetic. Okay, I know you do.
Well,
What goes in the box for synthetically dividing these?
6.
Positive 6. Good. And then I'm still a little worried because I saw this on a few people's tests. Yeah, there's a 0 in there. Thank you. 1, 0, negative 4, and 8. Oh, fool me once, missing term. Shame on me. No, shame on you. Shame on you. All right.
Shame on you.
Shame on you both times. All right, guys. Don't forget your missing terms. I think all of us have been burned by this before. Let's stop being burned by it, okay? All right, 6. We got 36. I don't even care about this part. Remember, your oblique asymptote has nothing to do with the remainder. And then, gosh be golly, if someone does this to me on this test, I'm just gonna like burst into tears.
Y equals.
Oh, yeah, I get this. And they're like, what? I did your division.
It's an expression.
That's an expression. We need an equation. So the guys are telling me to just throw a y equals in front of it. And I know that seems really picky, guys, but I have to be picky about that. In fact, I think...
It should be inferred.
Implied, yes.
But you should infer it.
I should infer it? You mean with bolded, capitalized, and underlined letters on your test?
You should infer that there's supposed to be a y equals there.
Should I just write it down for you? Should I like hold your hand and write your pencil for you? All right, so we're all going to get that question right this time, yeah?
Yeah.
Yeah. All right, moving on. I think we're... Okay, you know what equation is. I don't think this is on a worksheet anywhere, but this would be a really good one for us to practice with. There's one like this on your test. So you're going to create a rational function. Now, just feel bad for me. These are really horrible to grade because there's not just one right answer. There's a whole bunch of right answers. So I got to figure out whatever you create if it has all these things going for it. So we have a whole at x equals 2. So I know that means the factor will look like this, but tell me where the factor of x minus 2 is located. Okay, it's located in both the numerator and the denominator. That's what a whole would look like, a removable discontinuity. Okay. This is, I don't think, on any page. You're just watching, guys. A vertical asymptote at x equals -3. So I know the factor looks like this, but where is it located if it's a vertical asymptote?
On the bottom.
Mm-hmm. Now, if I have a horizontal asymptote at y equals 0, if my end behavior flattens out, or y equals 4, flattens out to y equals 4, I'm supposed to have an equal weight with a lead coefficient of 4. I don't have equal weight right now. And I don't have a 4 either. So at the very least, I need to throw a 4 in front.
And then an x.
Okay, that would work.
A 4x.
So there was nothing in that problem that said, like, you can't throw me an extra x-intercept. So, oh well, I did. I had to know that it was equal weight before I moved on. That's right. Yes, Jemai. It could have been anywhere. It could have been anything. So that these are hard to grade because then I get kids who like throw extra factors for fun.
like extra removable discontinuities.
Yeah, yeah, it's cute. Maybe don't get creative on this one, but yes, the 4 has to be there, and then what I wrote in black could be any factor, and it could be anywhere in the numerator.
Does it have to be factored out, or can I bring them back together?
Do you really want to do that to me in the middle of grading your test? I don't know if you know this little secret about teachers, but the angrier they are,
the harder they grade.
The harsher they grade. Just remember that.
Don't be laughing.
Don't worry, kids. I'll save Daniel's test for the end. I'll grade his after all of yours are done. Then I'll just have all that energy to take it out on your test. All that anger. Nope, you're my last class for PreCalc. You're it. All right. Here's my concern. A long time ago, and I'm talking like, gosh, I think it was after homecoming weekend. Like, we're talking homecoming time, guys. We had a worksheet that was called, like, Remembering Rational Operations or something.
Yeah, I remember that.
Mm-hmm. I don't know if many of you did that.
I can almost guarantee you.
And here's my thought, just thinking like a teenager. We did the worksheet. We did one side together, and the other side was, like, on your own. And a lot of you went, oh, this was easy. We did this in Algebra 2. I'm really good at these. And that's great, and I hope that's the truth. I don't know if you actually practice them ever, so I'm wondering if... It's on your homework check. It's number 1 in your homework check, so you should do it.
It's almost done.
Really? Good on you. Okay, so 5th graders, how do we add and subtract fractions?
Common denominator.
You need common denominators. What's going to be your common denominator in this question?
M plus 1 times M plus 1.
Yeah, and we leave it built into factors. We don't need to do anything there. So we're back on the review right now, guys. This is my goal for a common denominator. Neither one of them have it. So this needs to be multiplied by an m plus 1. Yes, and this needs to be multiplied by an m plus 5. Now you don't have to do any work in the denominator. That's all set up. All your work happens in the numerator. And this is actually where all the mistakes happen as well. Like, for instance, I just covered up that subtraction sign. That's a bad idea. Okay, so this numerator, if we distribute everything here, you get 6m squared. And then plus 30m. but this is where I see mistakes. We are distributing a negative 2m into this. So you have a negative 2m squared and then a minus 2m.
So
Clean that up.
4m squared plus 28.
Yeah.
Over.
And then don't do anything there. Yeah, just leave it factored. And this is actually a great answer. But I'm running the risk of forgetting something very important. Sometimes my math teachers throw questions at me where they factor and cancel at the very end. So like this numerator, technically you can take out a 4m. Now, we kind of lucked out. If we forgot this step, nothing cancels. So you don't really have to worry about that step in this particular question, but you know.
But even if stuff cancels, the equation or the expression is still true.
It's not simplified. But it's not simplified. So you would get it wrong. I'd box it in, and I'd say, keep going. That would be a nice 4. If that's what you did. I'm going to be honest, I don't think we did that to you on your test. There's a lot going on in this test, and I don't think we were, like, looking to make you fail or anything like that. We're trying to give you some very general, basic, pre-calc-worthy examples that weren't horrible.
That's nice of you.
For once, yeah, I know. All right, so here we're dividing fractions, but 5th graders don't divide fractions. What do? Yes, they change it to a multiplication problem, and they can only do that because they're going to take the reciprocal of the fraction that follows the division. So we're going to multitask here, guys. We're going to factor and rewrite it and flip it all at the same time. This guy factors by taking out a common 9x, and that leaves you with x minus 5. And then that first denominator factors pretty nice. Minus 8 minus 5. And then we change it to a multiplication, so that's good. Now, this guy, this 5x to the third thing factors by taking out a 5x squared, good. But now it's in the numerator because we flipped it. So it's 5x squared times x minus 1. And then the 9x doesn't cancel or factor or anything. Well, it does cancel, but it doesn't factor. All right, so now it's all one big problem. So anything that shows up in the numerator and denominator is gone. Sometimes kids get a little too excited about canceling things, and they're a little aggressive in it, and I can't read their work anymore.
So x minus 5.
X minus 5's cancel, thank you.
So we just need to cross them out. We don't have to, like...
Yeah, no, please don't blacken them, because that's really hard to grade if you get it wrong. And I think that's it, right? So I wouldn't even bother to simplify it. Just leave it as 5x squared times x minus 1 over x minus 8. And then there's some kids out there who tell me to cross off the x's. I love how you guys laugh at those fools.
But there's no correct.
But those implied parentheses, man. They're not there, but they're implied, and we're supposed to know it. And welcome to PreCalc. That's like, I'm sure you've heard it from math teachers before. You've learned this before, so this should be easy, right? I try really hard not to say that. But I know sometimes it's what I'm thinking. But that doesn't mean we learned it to mastery, so maybe let this be your moment, guys. All right, so we're on the review. We're looking at a rational equation, and my motto is I hate fractions and equations, so we're going to try to get rid of them. So this first one, I'm going to do the long way, and then I'm not going to do the next one the long way because it's a lot of writing. So you look at your denominators, and the first thing I'd like you to tell me are what are some solutions that I can't have at the end of this problem? Or what is a solution that I can't have?
0.
I can't have 0. So if I get to the end of this problem and I find out that a equals 0, then we're going to have to cross it off because it's extraneous. Well, it's not wrong. It's just extraneous. The answer is not 0, though, on this one. What is my LCM? I got to knock out all my denominators. So give me something big enough that knocks out everything.
3.
A 3 and an A. Oh. Now, a lot of kids look at this and they say, don't you need more than one A? Because there's like an A and an A and an A. They have a common A. It's not that you need multiple A's. Okay. So that's why we shoot for the least common multiple, not just any old common multiple. So here's what the long version of this looks like. You write the 3A minus 1 in front of each of your terms. Now, I would caution you that if you have a polynomial, oops, it's an A, like we do here, you might want to put it in those implied parentheses we would love. Yes, they're there. And then one more. So now each one of these problems becomes their own little tiny simplification problem. And this is the step that ideally we're going to do in our head, but I know it's a test and maybe you're nervous that you're going to do it wrong if you don't take this long step. On your homework though, try using a little bit of a shortcut. You know, that homework you already did. So talk to me about this first little bubble. Does anything cancel? Something better, because we're not supposed to have denominators anymore. Yeah, the a will cancel. So you have 3 times 4, better known as 12. Alright, there's the next bubble. The 3 and the a will cancel, leaving you with nothing other than the existing numerator. So you still have an a squared plus 4a minus 12. Now if there were something here like a 2, you'd have to distribute it into that parenthesis set, so watch out for that.
Plus 3.
And then plus 3, because here the a will cancel again and you get 3. Now, I think I warned you about this before, guys, but when we test you on these questions, we have designed them in a way where you get something that's very easy to solve. So it's either going to be a quadratic that factors beautifully, or it's going to be a really boring linear statement that you can just solve. So if you get down to a quadratic or something that you can't factor or solve easily, you've messed up. So bad news. All right, this is a quadratic that factors nicely if you get everything to one side, so we have standard form. Let's see here. We got a plus 4a. And then a minus 21 when you collect all these constants. So you get factorization of, let's see, a plus 7 times a minus 3. So your two solutions are a equals negative 7 and a equals 3, neither of which were 0, so you get to keep them both. If for some reason you end your test with 10 extra minutes and you have nothing better to do with your time, this would be an easy one to check. But you're pretty confident if you got to this line and you're like, nailed it. Quadratic factors, love it. All right, this next one. I would like to take the shortcut because otherwise I have to write all this out again and no thank you. But before I talk about your LCM, you have to recognize that 2 of these denominators are factorable. So like a to the third plus 5a squared, you have to see it in terms of its pieces. Can we factor out an a squared?
Yeah.
So this becomes a squared times a plus 5, and that's the same denominator over here. Now here's why this is so important. This is the step that a lot of kids skip in Algebra 2. They just start multiplying by like whatever they want because it happens to work out. If you don't come up with the least common multiple here, and you end up multiplying by like a to the 5th or 6th or something eventually, like that's a lot of terms that are going to be extraneous, and you're going to get something that you can't even solve. So you need to shoot for the least common multiple. So now take a look at all your denominators and give me a list of things that I need to cancel out. A squared. What else? Well, you already told me a squared, so I don't think I need to say it again. So a squared and a plus 5. This is the least common multiple. This is a listing of everything that you need to cancel. So here's what the shortcut looks like. When I go to distribute this LCM into this fraction, you guys okay with me saying that the common denominator, or sorry, the denominator and the LCM just knock each other out?
Yeah.
So I don't need to write it down at all. I can just write down that numerator. So basically, I'm only writing down things that don't cancel.
Okay, and this one you're just going to write
So
down
in this term, the a squareds are going to cancel. So you still have this plus sign. You still have the a minus 3, which is in parentheses because it's a polynomial. But you still have to multiply it by the a plus 5. He did not cancel. Yep, and then in this last term, it all cancels again, so you just have a 1. So you do have a little bit of work to get to your nice quadratic. This guy foils out. Let's see here. We have a squared minus 8a plus 16 still, but then here becomes a squared plus 2a minus 15. And then teacher promised me that if it was a quadratic, which this one is, it should be a nice factorable quadratic. So just take your time collecting all your terms. You guys end up with 2a squared. And then if you collect all your a's together, let's see, it's a minus 6a. And then the constants actually cancel out. Because this is a 1, and then you subtract that other 1 over for standard form, and they're gone. This is a factorable quadratic. You can factor it by taking out a common 2a. Oh, you know what I forgot to do? Way back at the beginning, guys. Tell me what I can't have. Can't have 0, and I can't have negative 5. Look what we're about to get. If you set this guy equal to 0, it gives you a equals 0. But didn't we just say we can't have it? So that's extraneous. And if I set this guy equal to 0, I get a equals 3. That one I can keep. Okay, so that was a case of icky LCM, a little bit of work, got a quadratic, 2 answers, one of them was extraneous, the other one's good, move on. Fun times. More of that, right? All right, so these are the ones we've been doing over the last few days here, guys. These are the inequalities for polynomials. I want you to keep doing what we found to be successful. There's going to be one poly and one rational. So I want you guys to find your x-intercepts through whatever, really, it could be any method you want. So some kids are like, can I just graph it? And the answer is yeah. But this one does factor kind of nicely. Just FYI, think about factoring because it's very important for pre-calc. This factors into x times x minus 7 times x plus 1. So when I solve those factors, I get a 0 at -1, at 0, and at 7. And if you graphed that on your calculator, just the polynomial, you would see that. So I'm just going to pretend that this is actually to scale, which it's totally not. But your polynomial is going to look, you know, something like this. And this is where I bust out my colors, right? So this is below the x-axis, and so is it right here. And then here's where it's above the x-axis. And for those of you who are so good at domain intervals, like you got it right now, you know exactly where the answer is, that's awesome. Some of us aren't there yet. So what we're going to do is we're going to transfer this over to the sign chart here. Before the -1, it was negative. Between -1 and 0, it was positive. Between 0 and 7, it was negative. And then 7 and beyond, it was positive. So they want to know where your polynomial was greater than or equal to 0. So they want to know where it's positive or equal to 0. So they're looking from here to here. And why am I using brackets? Inclusive, right. So -1 to 0, union 7. And then we never use a bracket on infinity, so I know to use a parenthesis there. So this little sign chart combined with the graph and using colors, because I love colors, you get a really nice setup domain interval for yourself. I think that would be a great way to approach this. Now the next one is rational. This is the version that you type on your calculator because it is already 0 on one side. So this gets typed into y1. Don't forget to use parentheses here though. But the algebra version, where you can see your x-intercepts and vertical asymptotes, has to be when you get common denominators, right? So if the bell rings and you guys leave, it's okay. I'm just going to keep recording. Just FYI, I'm going to pull a Hochbauer. I know you're like, the bell's about to ring. All right, so getting in my common denominators, this denominator obviously is nothing special. It's just 7 times x plus 3. I'm going to leave it like that. But my numerator, when I collect all of my like terms here, let's see, this guy becomes, I'm going to simplify it in my head here, so this is dangerous. 35 minus 6 is plus 29. Okay. This is the version that I use over here for finding x-intercepts and y-intercepts. So my x-intercepts are critical points. It's when I set my numerator equal to 0. So setting this guy equal to 0, you have an x-intercept at 29 halves, which is like 14.5. And then your vertical asymptote is your denominator equal to 0. This guy doesn't equal 0, so don't worry about that, but this totally does. You have a vertical asymptote at -3. So what you would do next is you would confirm all this on your calculator. You're going to be seeing a vertical asymptote at -3, and then way out here at like 14.5, you have an x-intercept. And then I think it looks like this, something horrible like this. Not really sure, but something like this. And then you can start color coding. So we got our negative piece here, and then after the intercept it's negative, but up here it's positive. And I really like when this is set up as a sign chart because it just helps with the domain interval. So the vertical asymptote was 1 point of criticalness, and then the 29 halves is the other one. So the rational was negative before the asymptote. It was positive after the asymptote until it hit 29 halves, and then it was negative again. So they wanted to know where my Rational was less than 0, so we're looking from here to here and here to here. Now, on that particular question, there's no brackets because there's no equal to symbol, but make yourself a little special note that at the asymptote, you can never use a bracket, even if you wanted to use a bracket because it had equal to, because it can never hit the asymptote in those vertical asymptotes. So your domain is from negative infinity to negative 3, union 29 halves to infinity. So taking a hybrid approach of using your little sign chart for domain interval, but also looking at your calculator, also looking at your algebra, everything should match up. All right, good luck.